Hi, everybody. Welcome to the August 2021 version of Libraries Connecting Texas webinar. I'm so glad that y'all are here. This is always my favorite presentation of the year because we get to have a special guest. Charles Thacker is here. He's our IT director, and he's going to talk about bandwidth and how, just what it all means and how you can determine what your bandwidth needs are and what kind of technology that you might need. I'm Caroline Wolf, and we have Jenny Harwood, Jennifer Williams, Patty Hollingsworth, Brandy Krupaw, Kyle Lewis, and Charles Thacker. Charles is actually having some internet problems, so he's going to probably just hear his voice and not see his face, but we're gonna roll with this as well as we can. So we're gonna give you some information about what's going on in E-rate, and then we're gonna let Charles talk. So that's right. So move forward, Jenny. I think there was a slide that didn't update. That slide didn't update with all my updates, but that's okay. Go ahead. There we go. So 57% of the funding for Library Connecting Texas Libraries has been dispersed for 2020 requests. That's awesome, considering that it's August and the funding year ended in June. So that means that either you've filed bears or your service providers have been invoicing USAC for your discounts. So right now, 18 LCT libraries still have no disbursements for 2020. Don't panic yet. We've got a couple of months to do those invoices, but just make sure that you're checking your bills, or you go through your bills from 2020. That would be July 1st, 2020 through June 30th, 2021, just to make sure that if you were expecting your service provider to discount your bills, that they did do that, and that and if you have a question about whether or not you've gotten your dispersals, we can let you know. We'll start running reports of the libraries that haven't gotten disbursements yet, so we can remind you if you're one of those libraries. But $480,534.41 has been dispersed to LCT libraries for 2020. Congratulations. The ones who've gotten that money are the ones who are E-rate successes. So we're ready to go to the next slide.
I am going to stop sharing so we can transition to Charles's presentation. Give me just a sec. It didn't want to open two at the same time.
While Jenny's doing that, I just want to let everyone know that if you have any questions during the presentation, you can raise your hand, or you can ask questions in the Q&A, which should be a selection in your Zoom toolbar, or you can use the chat. We're happy to answer any questions that you have.
Good afternoon, everybody. This is Charles Thacker. Yep, I'll go ahead and start my little section of the presentation now. It's a pleasure to be able to present to everybody. And I know I've had a chance to do this in the past, and it's maybe a little bit repetitive for some attendees. Of course, repetition always helps, though, learning new content. And so we're going to go over a little bit about understanding bandwidth needs internally and externally, meaning inside your network, and then also your internet connection. And I do honestly think like there is quite often never enough time, money, or bandwidth now. We can always use more, and that seems to be a growing trend. I am the Director of Technology for E-rate Central, but I do come from a public education background. So I come from that public space. I do definitely have a lot of support and affinity for library systems as well. So I'm happy to be able to help out where I can. go into the next slide and we'll start talking about some network considerations. And what I like to do when I look at networks is think about a water pipe. Think of a garden hose or a drainage pipe, anything. And we're going to be looking at how much water we can flow through these pipes. And water in this case is going to be our data. And the numbers that I'm going to put on these pipes, they could be anything. They're going to be megabits per second for networking, but think of them even as miles per hour, perhaps, as if you're driving a car. The faster you go, the higher that number is. So we want higher numbers. And if we have a network that has maybe a 54 pipe connected to 100, maybe your core network is 1,000, and then maybe our connection out to the internet might be 100. When all is said and done, the best speed we have out to the internet in this scenario here is 54. It's not that great big 1,000 that we like in our core network. It's just going to be 54 because everybody's coming through that very narrow pipe at the beginning. So if we add a couple networking pieces of equipment here as an example, we've got a computer connected to a switch, and it's going to have a nice high speed, maybe 10, 100, could even be 1,000 coming into that switch. But then that switch is going to be connecting out to the internet. What are we actually getting for internet speeds? So we're going to look at a little bit more complicated network diagram on the next slide that puts these pieces together to talk about that limitation. You might also have wireless access points on your network. You're going to have different speeds with those connections to clients. And again, that access point connects to your network. But we're going to have to do some calculations to figure out how much speed is each client actually getting, and what is it that you're providing to all of your patrons and your staff within your network. So on the next slide, we'll add a little more complexity to it. And we're going to have these same network considerations. You have a core switch, and let's say you have a 100 megabit per second connection to the internet. We'll just start with that because it's going to make the math really simple. I want to make the math simple, predominantly for me as I present. And then we're going to add some other items to our network. We have an access point, and it may be connected with a nice big 1,000 connection to our switch. And then we add in some clients. And those clients might be connecting, again, for convenience. Let's just say they're connecting at 100 megs to your access point. But that's 5 clients. Let's add 5 more clients in there. So it's a nice round 10 number. We have 10 clients connecting at 100 megabits per second to your access point. Your access point has 1,000 meg connection to your switch. And when we do the math on that one, it's nice and simple. We divide by 10. So go ahead and click one more and we get divide by 10. Every client here has this 100 meg connection to your access point, and they get 100 megs into your switch. It's nice and convenient. However, what really matters is that lower number down going to the internet. Because we're dropping everybody down through a 100 meg pipe, we now have to divide that by 10, and each client is in fact only getting 10 megs out to the internet. If they're all active at the same time, there's a few factors obviously involved here, but everybody is now getting 10. So going to another click there, Jenny, this is our bottleneck. Our bottleneck is our internet connection. And we do want to push our bottlenecks as far away from ourselves as possible outside of our network. But at some point, that's going to become your internet service provider. And you want to make sure that you have a nice, robust internet connection to handle all your internal traffic that's going to be leaving. So just bear in mind this concept of that smallest pipe is your most limiting factor when you're dealing with your internet connectivity. And you want to have as big of pipes as you can everywhere along that chain, from the client to an access point or a switch, from the switch out to your internet. You want to make sure that you don't have any small pipes that become the bottleneck. And if you do have small pipes, try to push them as far away from you as possible out to your internet service provider. The next slide that we have is a little bit left over from when we're dealing with traditional E-rate, and I know that your team will be talking about ECF opportunities as well, which doesn't quite fit in exactly with this, but we used to break down within this presentation a little bit just to kind of show you which pieces were category 1, which would be your internet connection, which pieces are category 2, your internal connections, and which things are not eligible, which would be those endpoint devices. However, ECF does introduce an opportunity to change that. And so your E-rate team will be talking with you more about that, I'm sure. Now that's a little bit about the bandwidth. Now let's talk a little bit about the types of connections that you could have out to the internet. So we'll hit our next slide. And we're going to talk about these internet connection types. And not all of these are equitable. So there are several factors to consider when you're looking at different types of connectivity. Number 1, availability, because it doesn't matter how good it is if you can't get a hold of it. So you want to make sure that whatever technology you're looking at is truly available in your area. Affordability. Can you afford what is being offered? Because if you can't afford it and you can't acquire it, it doesn't matter how good it is. The reliability is very important. If it is not going to be reliable, then you're spending money on something that your patrons and your staff are simply going to be frustrated by. And we want to avoid that frustration as much as possible. Speed might almost be the last thing that you're worried about, just because, again, if you can't get it and you can't afford it, it doesn't matter how fast it is. But you do want to make sure that when you do have something that you acquire, it has enough speed to handle everything that you need for your work, for your staff, for your patrons. So again, your staff can do their job and your patrons have a good, enjoyable experience and aren't frustrated by it. So the next slide talks a little bit about our major technologies. And there are more options out and available than what I'm listing here. And within some of these, there are some finer tuned concepts. So within wireless, perhaps there's some different types of wireless in there, but these are the major categories that you might run into with your internet connectivity. Fiber is going to be the item that has the highest speed and the highest reliability. And coming along with that is going to be its most expensive solution as well. So cost is going to be a factor there. It's also the least available in many areas. To have fiber directly to your business or to homes generally means that you're going to be living in a pretty large metropolitan area. Most ISPs are not building out fiber into some of the less populated areas, certainly into rural areas. It can be very difficult to get a hold of that fiber. Cable has a higher availability, mainly because cable companies have really invested in that entertainment industry and trying to get out into homes. And so they have a lot of infrastructure built up. So it's available in a lot of areas. And it has pretty decent speed and it's a pretty competitive cost as well. A DSL, or a digital subscriber line, is something that's offered by telcos or by telephone companies. You might get them from your landline company, AT&T, CenturyLink, etc. It's pretty widely available because the phone system is widely available. Most homes have phone cabling to them. And so you're going to have this available almost everywhere, but you are going to be suffering from lower speeds. There's a limitation on how fast DSL can be, and you will have a little bit lower cost to go along with that. Wireless is growing. And again, there's a variety of types of wireless that you might be able to gain access to within your area. It is growing in availability, and it has middle speeds and costs depending on the ISP that's providing it. And satellite is a widely available option simply because you simply need a good southern exposure to the sky in order to be able to leverage satellite. And so essentially 100% of the United States is covered by satellite internet availability. However, it comes with lower speeds, definitely a higher latency, meaning a little more lag, and we'll talk about that a bit, and certainly higher costs. So let's go into some of those technologies a little bit more individually. Next slide, Jenny. Fiber, again, highest speeds available. You can get several hundred megabits up to even multiple gigabit connections with fiber, depending on your provider. And a very important factor of that speed is it is generally symmetrical. What this means is that your upload speed and your download speeds generally match. This is not the case for most of the other technologies. And that is very beneficial when you're dealing with, as we are now within our new environment of working from home and remote work, remote schooling, having video conferencing systems in place where you are sending video as well as receiving video. And so you want those upload speeds to be high, and a symmetrical connection that fiber can provide can be very beneficial in that regard, especially if you are dealing with a single point of location where you are serving multiple people. So your multiple patrons and your staff, working with small businesses, libraries, schools, a dedicated fiber connection that has symmetrical speeds is going to be incredibly valuable to you. It also has a very high level of reliability and future proofing. Fiber has a very long lifespan. There's fiber in the United States that is 30, 35 years old and is still working perfectly fine as long as it's maintained well. So when you acquire a fiber service, you are generally not going to be running out of the technology availability from fiber. That's a poor way to say that. Basically, you're going to be able to leverage that fiber for longer than you would some other technologies. The downside with that is it's not as readily available outside major metropolitan areas. It's growing as providers build out fiber, but it is not yet at a point where it is going to be readily available for everybody. So it may not be something you can acquire. It also comes with a higher total cost, although if you do the full calculations, you may find that the cost per meg is really actually lower. It's just that you're going to have to secure more speed and more bandwidth, which means that the total cost might be higher than some other solutions. However, I think you're going to get your money's worth out of that solution. The next technology that we'll cover in a little more detail is cable. So we'll go to the next slide. And we have high speeds available here as well, generally depending on where you are located and what your provider can give you. Several hundred megs, sometimes even up into the gig area. It is, however, generally asymmetrical. So in this case, the upload speeds are not going to match your download speeds. Your download speeds might be several hundred megabits, but your upload speed might actually be down in the single digits, potentially up into 10 or 20, depending on what you're willing to pay. That is going to be a factor, again, when you're dealing with video conferencing, where you need to be sending data out to someone else rather than just pulling data down for yourself. So think of the download piece as you are watching a video and you're just receiving it. You are browsing, you are doing email and receiving information to you. The download speeds are going to be what impact that connectivity. But when you're doing video conferencing, you're also sending your own video and your own audio, and that's where you want upload speeds to be high. You can also see, unfortunately, some congestion that can happen. So you can get lower speeds at different times during the day because you're all sharing that connection. A cable network is really a shared bandwidth connection technology. And your area, depending on how dense your little community is, your area is all going to be riding on that same connection. And you are all going to have to share it. So when people come home from work and they all get on their home networks and they start streaming Netflix, doing whatever they're doing, that's going to adversely affect your own speeds as well, because it's not dedicated just to you. The reliability, I was going to say it's good reliability, but I have to admit that's why I'm only on audio right now, is because I have Xfinity at my home and they had an outage, which has just been restored, but it's not going to be in time for me to be able to hook up with this presentation. In general, though, it does have a fairly good reliability, and it is readily available in most populated areas, again, because cable providers have really been working to get more customers, so they're going to spend money on those build outs into different areas. The cost can also be quite reasonable, depending on what it is that you're attempting to acquire for a service, and they are generally competitive. Do the next one is DSL. DSL is still out there, still being used. I think the technology is going to be kind of going away a little bit. A lot of people are completely getting rid of their landlines in general and not using them at all. So DSL may not be long for us. You'll get low to medium speeds from DSL up to a few hundred megs, and that's going to be pretty high if you got up to that. And it is also dependent upon how far away you are from what is called a point of presence, or the POP for your telephone company. The further away you are, the more that speed drops. It's also asymmetrical, so you're not going to get the same upload speeds as you would download speeds. And that bandwidth is dedicated to you, but, and I'm not sure if I had a note on this somewhere else, but you will generally not be able to get the full bandwidth that is advertised to you with DSL. It is almost always advertised at a certain bandwidth, but based on your distance and other factors, you'll find that you never really quite make it up to that full bandwidth that is advertised and that you're paying for. The reliability is as good as your phone service. So if the company that is providing your phone service is doing well and they can provide DSL, they're probably providing the same quality in both directions. It's, again, available in almost all areas simply because we have telephone service to so many locations now with the cabling. However, that distance, again, between your location and the point of presence for your telco company is going to be an impact on whether you can have DSL at all and what speeds they can offer. And again, their costs are also fairly reasonable, except that you're getting low to medium speeds. So they're appropriate perhaps for the speeds, but the speeds may not be good enough for what you need. The next technology is wireless. Low to medium speeds as well. There's several factors as to why that might be. They can give, generally ISPs can provide, up to a few hundred megabits per second service. It is also asymmetrical, so you're not going to get the upload download to be the same. It might be a little closer though. The data caps can also be put in place. So with wireless technology, your ISP may say you can have this speed, and here's your download, here's your upload, but you're also going to be capped as to how much data you can transfer in a given time period. Normally that's going to be the billing cycle, perhaps a month. And they may say you can have so many gigs of data transferred within that month. And if you go above that, they will either slow your speeds down or they will charge you for the overage. So that's something to bear in mind when you look at contracts and you look at agreements with service providers who are providing wireless service to you. It has a fairly decent reliability, but bear in mind, obstacles, trees, buildings, things like that, as well as weather can adversely affect those connections. This is going to be an antenna or a dish that is outside of your building, and it is a connecting to other equipment that the ISP is managing in other locations. And anything in between there can cause adverse effects. It can diminish your quality of your connection. The availability is growing in several areas, especially in those areas where it's hard to get cabling done. Wireless has been coming in to pick up that slack and be able to cover areas that may not have been easy to get cabled. And the cost can be medium to high, especially high per meg, just because of the way that the technology works, the infrastructure that companies have to put in play, and the fact that they are going to be capping you in some cases. So you might end up paying a little bit higher than you would like on those. The final technology we'll look at is a satellite, just to talk about some of the details of that. This is a growing market. I think some of you may have read about Starlink coming up, which is SpaceX and Elon Musk putting out low orbit satellites in order to improve speeds for satellite connectivity. HughesNet has been a player in this area for quite a long time. There are a few other players. Amazon, I understand, is going to be stepping into the ring as well to provide some satellite connectivity. And this is great in the concept of the availability. I'm going to jump down a bit. The availability is huge. We can cover, in fact, most of the globe, except for the extreme north and southern poles. But you're going to deal with low to medium speeds. You can have maybe up to 100 megs, maybe a little bit more on some of the higher end services. It's still going to be asymmetrical. Your upload speeds are not going to match your download speeds. The bandwidth is dedicated to you, but they may put in those data limitations. They may have caps on how much data you can push through that network during your billing cycle. The bandwidth is good in regards to providing that service, but you're going to have this high latency, mainly because of the distance that all that signal has to travel going up to space and back. And so you get this higher latency or a delay or lag. And that can cause problems for gaming. I'm not sure that many libraries are focused on gaming and whether you care about the lag that might happen there. You may hear it from your patrons though, but you're going to have that with video conferencing. So if you have audio and video calls that are going on, you might notice that delay and lag if you're dealing with a satellite technology more so than other technologies. Again, the reliability is fairly good, but obstacles and weather can affect that connectivity. The availability is high, but you're also going to have that high cost. And again, especially when you do the calculation to how much does it cost per megabit, and you are going to find that it's satellite, it's a fairly spendy solution. But in some cases, it may be your best option. If we were looking at all of these together and going to rank them, if you can, if it's available and you can afford it, this would be my recommendation for what you should be looking for. A dedicated fiber connection, because it's not the only kind of fiber connection you might have. Right after dedicated fiber connection would be a shared one. And this might be called something like Metropolitan Optical Ethernet or a Metropolitan Area Network. This is fiber that an ISP has put in place, in which comes to aggregation points in their own network across a city or a metropolitan area, and you have a connection into their network, but you're sharing it with all of their other customers. So you will be seeing some changes in what kind of speed you might get based on the utilization of that network, but because it's fiber and because the bandwidth will be so high, you may not notice it too much. So either fiber dedicated or fiber shared would be preferred over the others. Cable, I think, would come in next, just based on its reliability and the speed options that you have. And then finally, kind of wrapped together would be these other services of DSL, wireless, and satellite. And again, it's going to be based a little bit on what you can afford and what is available to you as to which one you might have to pick from that group. Now, how much speed do you actually need? My concern when we look at how much speed you need is that we often end up in this scenario where we have invested in our internal connectivity a lot. We have maybe purchased some really nice tablets, some really good laptops. We've gotten some powerful phones out there, and maybe your patrons are arriving with these very powerful machines to hook up to your network. And that's like they have a sports car. They have this great sports car, but you are then unfortunately only able to provide a slower network, which is a little bit like a dirt road or a bad road. So you have these really super fast cars on bad roads, and it's not a really fun experience for anybody. And that poor experience can cause people to lose their confidence in your network's availability and usability, not just for the patrons, but also for your staff. They can be frustrated because they're just trying to get their work done. And when that frustration builds up, people stop coming to use your network. You stop getting as many visits from your patrons. And I don't mean support visits. I just mean that, and the wording on that is a little bit odd, but the patrons supporting you through their visits tends to drop because they can't feel like they don't feel like they're getting the most out of that network that they could. So how much speed do you actually need to avoid that? Well, unfortunately, I hate to use the lawyer term, but it does depend. And it's generally more than what you have. So if you can go for more, always go for more. So we'll break down a little bit about the calculation. We only have a couple slides here to kind of wrap this up. But measuring your need for speed. On the left, we have some basic ranges that you might need for some common tasks that you would be using technology for. Streaming video would be 3 to 25 megs per user. Always make sure that we are multiplying this by how many users you might think are using that technology. Now, that streaming video has a big range because you could be streaming fairly low end, maybe some YouTube things, or you could be trying to do really high quality 4K HD video. So you have a big range on that megabits per second. For video conferencing, most of those systems are wanting somewhere between 1 and 6. As an example, Zoom says you should have 1.5 megs minimum. I think that's a little bit low, to be honest, to be able to have good quality video conferencing. But 1 to 6 megs for your video conferencing, again, multiplied by how many users you have. Email and browsing is the lowest. It is about 1 meg per second per user. And that is just for sending and receiving email, some basic web browsing. Not web browsing as far as I'm watching a movie on Amazon Prime, right? That goes back up into your video streaming. And if you're doing an online learning or working environment, you're basically combining all those things above into a single environment. So you're going to need a good 10 to 25 megabits per second if you expect people to be doing full online learning and working. And as you do these calculations, and you take your megabits per second for the different technologies, you multiply them by how many users you think you're going to have. Bear in mind the things on the right. Don't forget you have patrons and staff both. So you have people who need to be working regularly within your environment. And then you also have this fluctuating number of users coming in, these patrons that are going to come in and use your network. And how many users do you think you might have as a max at any given time? That's what you should start looking at. Don't look at your average. The average is helpful and good to know, but you are always going to want more bandwidth. So if you look at your maximum users, that's going to help you get a little bit better bandwidth. And you are probably going to have multiple users per device. I don't know what the average right now is in the United States. It's probably somewhere between 3 and 4 devices per user in a household that are actively being used on the internet. And so you're going to have multiple devices per users using a variety of internet access things. Those are the items on the left. So calculate those in. Don't forget your regular business needs. Day to day, you have your staff working on things, and they're going to need that access. Also, don't forget you might have special events. Are you going to be hosting very large groups of people? Are they going to be coming into your space and using your network? You're going to have a large number of people that you need to factor in. And finally, are you hosting any services on your own network? You might not be. Your website, your card, I'm assuming it's still called a card catalog service. But your catalog, which is now predominantly online, I'm guessing, might be hosted outside of your network, and that's fine, but it also means that people are going out through your network to get to it. If you're hosting them on your network, you might be conserving internet connectivity for everybody that's in your library accessing your website or your catalog. However, everybody from the outside world who is visiting your website or catalog is now using your internet connection to come into your network. So bear in mind those services you have. And is your phone system maybe a voice over IP or a VoIP system? And so you're using your internet connection for your phones. You should factor that in as well and talk with your phone provider to figure out how much speed you might need for that. So we take all of these things together. We take all the data from this entire slide deck, we add it all up, and then we add some more. Always add a little bit on there, top it up so that it goes up to a nice round number of what you might be looking for from an ISP. And I think that's going to give you your best chance at success for having a proper internet connection that's going to give you the bandwidth, the reliability that you need for your patrons and for your staff. And so I want to be able to take a moment and just pause and allow any kind of questions, comments, concerns, even criticisms. I'll take them all, and we'll see what we get out of that.
I have something to add to actually what you said, Charles. Going back to what you said about the online card catalog, they're called different things, but a lot of them are basically called an integrated library system now. People are actually circulating books using their network. So those depending on the system that they're using to check out books, that information has to go back and forth on the internet as well. So it's something else.
Very good point.
Any questions? The reason why this is always my favorite one, and we do it in August, is because we're getting ready to start thinking about filing 470s and doing procurements for the 2022-23 funding year. So it's something that I think it's a concept that everyone needs to understand, not just librarians, but it's really important for you to maybe think about it in terms of how you're going to be filing for your applications next year. So one more last call for questions for Charles. Thank you so much, Charles, for presenting and for providing the information. We are recording this and we're going to provide it on our YouTube channel, but really appreciate your help. Thank you.
Absolutely. Not a problem. I apologize for the technical difficulties that we had.
It's the internet, right? So, September action items.
Okay, so thank you, Charles, and thank you, Caroline. Just to touch on a few action items for the upcoming month of September. As Caroline mentioned earlier in the call, the funding year 2020 bears, there are still a number of libraries that will still need to file a bear for those recurring services prior to the deadline on October 28th, 2021. Again, it's not a matter, it's not time to panic, but it is best to file that as soon as possible. Additionally, for funding year 2021 services, if you have not filed your Form 486 to certify with USAC that your library is SEPA compliant and that the services have started or will start, then that is due by the deadline of 120 days after the funding commitment decision letter, the FCDL, is delivered to you, or the service start date. Now, I think on a great many of your Form 471s, the service start date is July 1st of 2021. If it's later in the year, or if your FCDL has did not arrive until after that date, you want to go with the later of the 120-day timeline there. Finally, I think I included a typo here. That should say planning for for funding year 2022. My apologies for the typo. As Caroline had mentioned, in September is a great time to start potentially filing a Form 470, or at least getting your plans together for filing for a Form 470 for funding year 2022. And, you know, this presentation is really good, that Charles provided today is a really good way to consider, you know, what your internet needs at the library are going to be for the upcoming year, and look at all the options that might be available to the library at that time. And I'll pass it back to Caroline.
Thanks, Charles. So thank you all for attending today. We are really excited to be starting a fresh new year. I know that for many of you, August ends the fiscal year. I know for the Texas State Library that it will, and we're going to be continuing to help you through this next year. So we're excited to be working with you and any other libraries that are added to the Libraries Connecting Texas program. Have a wonderful rest of your month, and we'll see you in September.